Two possibilities exist. Either we are alone in the universe, or we are not. Both are equally terrifying. Arthur C. Clarke.
Confirmed. Finally. There's life on Mars.
My condolences to all of us.
What do you mean?
It's hard to imagine worse news.
Picture this. A junkyard contains all the bits and pieces of a Boeing 747, dismembered and in disarray. A whirlwind happens to blow through the yard. What is the chance that after its passage, a fully assembled 747, ready to fly, will be found standing there? So small as to be negligible, even if a tornado were to blow through enough junkyards to fill the whole universe. This is how astrophysicist Fred Hoyle once described the likelihood of life arising spontaneously. In reality, everything is much, much worse. The odds are smaller than if a tornado were to assemble a Boeing, not from finished parts, but from iron ore, molecule by molecule. And yet, life on Earth appeared almost right away, as soon as the planet cooled down and started looking like a planet rather than a fireball. How could that be? Some bacteria may have been carried here from space by a comet or asteroid. That's the Panspermia hypothesis, very popular. But it leads us straight into a trap, because if that's the case, then where is everyone else? If this is really how it works, the universe should be teeming with life, intelligent life included. But we don't see, hear, or detect any sign of extraterrestrial civilizations. It's about time we look for the error, in our calculations, in our observations, or in our entire worldview. Because the complete silence of space hints at grim conclusions. Are we nearing the end? In 1980, American mathematician Frank J. Tipler published a work titled "Extraterrestrial Intelligent Beings Do Not Exist." Why would a mathematician even write about this? And where does such certainty come from? Tipler simply pushed to the extreme the conclusions that had been drawn slightly earlier by another scientist. In 1975, astronomer Michael H. Hart published an article, an explanation for the absence of extraterrestrials on Earth. There, he raised a tricky question. What if just one civilization in our galaxy had mastered interstellar travel? What then? And right away, let's rule out sci-fi with faster-than-light warp drives and turn to something realistic. You'd have to travel on something resembling our own technologies, fair and square. We're only considering what we actually know. So, by his calculations, the entire galaxy would have been fully colonized in just 10 million years. Okay, with all caveats, no more than 100 million years. That is a ridiculously short period. Think about it, 100 million years ago, dinosaurs thrived on Earth. If back then, anywhere in the galaxy, among all those hundreds of billions of worlds, an intelligent civilization had appeared, even on the opposite edge, they would already be here. Later, other scientists refined Hart's model, making it more modest. Waves of colonization might not be separated by thousands or even tens of thousands of years, but rather hundreds of thousands. In some places, resources would run out. In others, there might simply be no desire. Not everyone would want to travel farther. Some civilizations might even degenerate and revert to a kind of medieval era. Here's a simulation of galactic colonization with very modest initial conditions. Maximum realism. Flight speed, 18.6 miles per second. quite an achievable figure. Travel time, a staggering 300,000 years, plus another 100,000 years at the new site to settle and prepare for the next launch. But even so, time and time again, the calculations boiled down to one thing: less than 1 billion years, and the galaxy would be colonized completely. Let's pause for a second and imagine what completely means. By various estimates, the Milky Way galaxy contains up to 400 billion stars. Not all of them have Earth-like planets, but the number is so staggeringly huge that even a tiny percentage means a lot. NASA stated that based on 2012 Kepler telescope data, the number of Earth-sized planets in the Milky Way can be estimated at around 17 billion. So, for every person on Earth, there are roughly 2 solid Earth-sized planets in our galaxy. Yes, it's like calculating GDP per capita. You won't suddenly get 2 planets of your own from that statistic, but you'll appreciate the scale. Okay, let's set stricter criteria. Count only planets in the habitable zone. In 2020, based on data from the Kepler and Gaia space observatories, NASA estimated that there are about 300 million such planets in the Milky Way. And those are only the ones in the habitable zone. Let us remind you, that's the region around a star where liquid water can exist for long periods. A key condition for the origin of life. The origin. But for colonists, this isn't even that critical. They can bring life with them, which means the number of planets suitable for settlement could be even higher. But remember, this would happen if only one single civilization in the galaxy mastered interstellar travel, on ordinary slow ships without any stargates or warp drives. And what if civilizations arise regularly? Then, during the lifespan of Earth-like planets, someone would definitely have arrived on Earth. Not once, and each time someone different. So maybe they did come after all. Don't rush to change the channel. We simply cannot ignore one hypothesis. Let's travel back more than 5,000 years. We're in Mesopotamia. It's around 3500 BC. At that time, things were pretty wild. Clay huts, tribes fighting over wells, chiefs settling disputes with clubs. No writing, no architecture. Science meant knowing how to sacrifice a goat properly to appease the heavens. And then snap, just a few centuries pass, and in this same region, cities are rising. Temple towers called ziggurats are being built. Legal codes appear. Schools are founded. Astronomy flourishes. Metallurgy advances, and ships are constructed. How did they manage to leap from centuries of barbarism into an age of development and prosperity? Who was behind all this? It's precisely such strange leaps in the development of civilizations that make us talk of Paleocontact, the hypothesis that ancient civilizations may have received knowledge from outside. In other words, from those who came from the sky. In Mesopotamia, these sky beings were called the Anunnaki. In Egypt, there were gods with animal heads. In the Americas, the famous deities of indigenous peoples. A recurring motif runs across all these cultures. Someone comes down from the sky and teaches humanity, and supposedly, it's they who left their mark in myths, legends, and ancient artifacts. Indeed, in some cases, these legends align in time with abrupt leaps in civilization's development, allegedly triggered by contact. But science does not accept the Paleocontact hypothesis. The reason is simple. There isn't a single convincing piece of evidence, no artifacts with extraterrestrial technology, no traces that couldn't be explained by earthly human causes. No, seriously, if even one single truly convincing piece of evidence appeared, truly convincing, not just loose interpretations, then skeptical scientists would have to acknowledge at least the possibility of such visits. But so far, the evidence offered is of about this level. If Egyptians had pyramids and the Maya had pyramids, then both must have been built by aliens. Well, come on. And yet, the very popularity of the Paleocontact hypothesis shows just how much we want to fill this gaping hole in our understanding. If the galaxy is supposed to be teeming with intelligent life, then why the hell are we sitting here all alone in the dark with no clue about what's going on? And if you're thinking, well, maybe they don't come for the same reason we don't, it's obviously way too expensive and too long. That immediately raises the same rhetorical question we'll keep asking today. What? Every single one of them? And what about signals? What about the so-called cosmic miracles proposed by Shklovsky? So what are these miracles? They're an intriguing and surprisingly compelling hypothesis put forward by the Soviet scientist Iosif Shklovsky. He noticed one simple yet powerful thing. If the universe were populated by civilizations, then we ought to see the results of their activities. Not necessarily spaceships, obviously that's unlikely, but at least something strange. Signs of engineering on a cosmic scale, stars whose light is clearly being distorted artificially, planetary systems behaving in ways they shouldn't, some inexplicable symmetry in the arrangement of celestial bodies. Or, at the very least, bursts of energy that defy any normal explanation. These are the kinds of phenomena Shklovsky called cosmic miracles. And here's the paradox: we don't see a single one. Everything in space looks as if no one has ever touched anything at all. And so Shklovsky concluded the very absence of miracles is itself a miracle. That alone is the anomaly, because it implies that intelligent life in the universe is vanishingly rare, almost to the point of impossibility. Otherwise, where is it all? Okay, let's be honest. Biological beings are, to put it mildly, not compatible with space, and it would be wise for us not to harbor any illusions about that. The human body was never designed for space. We evolved on a warm planet, under gravity, with 21% oxygen and powerful protection against cosmic radiation. We can't sleep for years. We can't endure isolation. Even with today's most advanced technology, a trip to nearby Mars would be torture for us, but more likely, death. To Mars, and we dream of conquering the stars. Machines, on the other hand, are a different story. Even at our current level of development, we've already sent all sorts of hardware into space. In fact, the Voyagers have officially left the solar system. But what if we could build something more advanced? For instance, machines capable of reproducing themselves from available resources. This was the idea proposed by American mathematician John von Neumann. He argued that the most efficient way to mine resources on moons or in the asteroid belt would be to use precisely such self-replicating devices. Since then, concepts like these have been called von Neumann probes. You launch just one replicable probe, it arrives at a new world, harvests local resources, builds replicas, and sends them onward. The sender doesn't necessarily have any sinister goal, like covering the entire galaxy with probes or anything like that. No. Even if these probes simply replicate and spread without any purpose, mathematically, the galaxy would quickly be teeming with them. They'd literally be dropping out of the sky onto our heads. Calculations show that a single von Neumann probe could, in just a few million years, cover the entire galaxy. But in reality, well, you know, not only are there no probes, we don't even hear any signals from them. Maybe no one ever sent them, or maybe something prevents them from spreading, or someone destroys them. And that brings us back to the now legendary question asked in 1950 by physicist Enrico Fermi. So, where is everybody? Perhaps Fermi asked the wrong question. Instead, we'd better ask ourselves, what happened to everybody? and immediately feel a chilling shiver run down our spines, because who's to say we aren't among them? And this isn't just a philosophical puzzle for idle debate or a fairy tale for science fiction writers. It's a real, harsh, and increasingly urgent question of survival. If, by all accounts, the galaxy should be teeming with intelligent life, yet we see no one, that's a problem. Something is off. And the answer to this paradox didn't take long to appear, but it wasn't exactly easy to face. In 1996, British economist and futurist Robin Hanson made a bold assumption. Bold because it tried to solve the infamous Fermi paradox, but at the same time, it was chilling. He put forward an idea: any organic civilization, from the emergence of life on its home planet to the point where it could master interstellar travel, must pass through several stages, and each of them is a narrow bottleneck. Here they are, 9 stages. Each one is a potentially insurmountable barrier. 1. A suitable star system. A stable star, a planet in the habitable zone. Not too hot, not too cold. As far as even the first stage goes, this is already hard. 2. The appearance of replicators. Not yet life, not even viruses, just molecules able to copy themselves. The initial spark. Chemistry with the potential to become biology. 3. The emergence of simple life. Prokaryotes, bacteria without a nucleus. On Earth, they dominated for 2 billion years. 4. The rise of complex cells. Eukaryotes. Cells with a nucleus, mitochondria, and internal structures. Only such cells would eventually evolve into plants, animals, and us. But this may be one of the rarest steps of all. It might have happened here purely by chance, and nowhere else. 5. Sexual reproduction. Yes, you heard that right. It's difficult. Reproduction through DNA exchange was a revolutionary milestone in the development of our civilization. It provided evolutionary flexibility. Without it, there is no progress, no complexity, and no chance at all. 6. Multicellularity. Cells joined into colonies, specialized and developed organs. From single-celled algae to dinosaurs and humans. But again, how many times has this happened? We don't know. 7. Tool-using animals and the rise of intelligence. Consciousness, self-awareness, the ability to plan, doubt, create culture and technology. How many species on Earth reached this stage? 1. Us. Suspiciously rare. 8. A technological civilization. Fire. The wheel. Writing. Science. The internet. It's about something more than simple intelligence. It's about intelligence that can transform reality. Hanson called this a civilization advancing toward the potential for a colonization explosion. 9. Explosive space colonization. The final game changer. A civilization that expands beyond its star and begins to colonize the galaxy. Once this process begins, it cannot be stopped. All barriers have been cleared. Yes, critics point out that Hanson's list is incomplete, but that isn't the point. The point is the principle. And the principle is this: at least one of these stages must be improbable. Civilizations simply don't make it to interstellar travel. Inevitably, they hit an invisible barrier. The barrier known as the Great Filter. And here's the crucial part. If the Great Filter is, say, the emergence of complex cells, then we can just relax. We've already made it. Congratulations. We are among the survivors, even if we don't yet see any peers. But if all those steps are relatively easy, if the universe is full of planets where life could have followed the same path, then the Great Filter lies ahead, waiting. And here comes one of the most unsettling thoughts in this entire discussion. We constantly hear about the passionate drive of scientists and enthusiasts to discover extraterrestrial life, any life at all. Even just a fossilized microbe on Mars, a bacterium beneath the ice of Europa, or some strange organic compounds in the clouds of Venus. That would be proof we're not alone, proof that life isn't unique, proof that the universe is alive. But here's the paradox. Suppose we do find the simplest life. Bacteria, archaea, traces of RNA. That would mean Hanson's stage 3 is not the filter. Life arises easily, frequently, spontaneously. Great news? Not at all. Because if the early stages are easy to overcome, then the great filter lies ahead. Do you see the problem? Ideally, we should be crossing our fingers that independently arising, simple, single-celled life is not found on Mars, Europa, or anywhere else in the solar system. Even scarier is if we suddenly discover fossils of complex life, eukaryotes, perhaps even something with limbs. The famous contemporary philosopher Nick Bostrom is starkly clear.
If we found the fossils of some very complex life form, such as of some vertebrate-like creature, we would have to conclude that such a discovery would be a crushing blow. It would be by far the worst news ever printed on a newspaper cover.
This would mean that nearly all stages, right up to civilization itself, are not unique. Life not only arises everywhere, it evolves everywhere, to advanced levels. And yet, space remains silent, which means the Great Filter is still ahead. And looking at how fragile our own civilization appears right now, it's hard not to wonder if it's already approaching. And if that's the case, it would help us greatly to have at least some idea of what it might look like. So, what is the Great Filter? The first idea that comes to mind is nuclear war, or some extraterrestrial equivalent. The logic goes, every civilization eventually invents superweapons and destroys itself. But this example looms so vividly in our minds only because we happen to stand so close to it as a civilization. Though, in all fairness, it would make more sense to begin with things entirely beyond a civilization's control. Things it cannot influence. From an eyewitness account,
I suddenly saw that directly to the north the sky split in two, and fire appeared high and wide over the forest. The split in the sky grew larger, and the entire northern side was covered with fire. At that moment I became so hot that I couldn't bear it, as if my shirt was on fire. I wanted to tear off my shirt and throw it down, but then the sky shut closed, and the strong thump sounded, and I was thrown a few meters. After that, such noise came as if rocks were falling or cannons were firing. The earth shook, and when I was on the ground, I pressed my head down, fearing rocks would smash it. When the sky opened up, hot wind raced between the houses, like from cannons.
this is a quote by a certain Semyon Semyonov, a subject of the Russian Empire. Back then, in 1908, something, either a meteorite or a comet, came crashing down over the Podkamennaya-Tunguska River basin. No fragments were ever found. Semyonov had the dubious good fortune of being just 43 miles from the epicenter of the monstrous explosion. By the most conservative estimates, its force was comparable to Bravo, the first American hydrogen bomb. That's 15 megatons, 1,000 times more powerful than the little boy bomb dropped on Hiroshima. So what was this enormous rock? What could have caused such devastation? Flattening forests across hundreds of miles. In fact, the blast was heard 1,000 kilometers away, and seismographs recorded its shockwaves all across the globe. 160 feet. Yes, that epic event, which still unsettles many to this day, was caused by a body just 160 feet across. And this is neither rare nor impossible. Our solar system contains millions of such objects. We can see some, but not most of them. And the only thing keeping them from wiping us out is sheer statistics. So far, we've just been lucky. Now, let's scale up that threat. On a planet like Earth, such a boulder falls once every few million years. In a galaxy with hundreds of billions of stars with planets, this is happening constantly. Somewhere, some civilization is likely being wiped out right now by such a cosmic guest. And of course, the problem isn't only asteroids and comets. There are also gamma-ray bursts. If you're unlucky enough to be in the path of hard gamma radiation from a supernova or some equally powerful cosmic event, the effects are catastrophic. A planet could easily lose 3/4 of its ozone layer, which would undoubtedly trigger mass extinction. Then there are galactic dust clouds, close passes of massive bodies that disrupt orbits, solar flares, and more. Space is unforgiving. At first glance, all of this seems like a perfect candidate for the Great Filter. But no. To qualify as the Great Filter, the cause must be universal, not one-off, not local, not random. Catastrophes are a lottery, a brutal one, but still a lottery. Some lose, others survive, and the universe is simply too vast. By pure probability, someone should have made it through. Someone should have reached us, or at least left a trace. But we see no one. We hear no one. So yes, disasters are terrifying, but they don't explain the silence. They are not the filter. We must look deeper. In 1841, British explorer James Clarke Ross led an expedition toward Antarctica. Having reached 70 degrees south latitude on January 28th of that year, the explorers saw something they initially dismissed. From Ross's recollections,
a low white line extending from its eastern extreme point as far as the eye could discern. It presented an extraordinary appearance, gradually increasing in height as we got nearer to it, and proving at length to be a perpendicular cliff of ice, between 150 and 200 feet above the level of the sea, perfectly flat and level at the top, and without any fissures or promontories on its even seaward face.
What at first seemed like nothing more than a faint white line turned out to be a barrier, one that even the bravest people on Earth had never faced before. This icy wall shattered dreams of a southern land and proved utterly impassable. For over half a century, no one managed to cross it. So it is with the universe. It feels as if everything is right there, at your fingertips. No, seriously, just think about it. Between you and, say, the moon, there's nothing. Absolutely nothing. No barrier at all. Just empty space. The same as between you and the cupboard, or the screen you're looking at right now if you're watching this video. No fence, no wall, no shell, no force field, nothing. That's strange, isn't it? Thus, Ross's expedition had no idea what unexpected barriers could emerge in the endless ocean. Likewise, we can look at something as a vague, insignificant white line on the horizon, and only when we get closer do we realize it's actually a barrier, and for now, we have no idea what to do with it. We're used to thinking that space colonization is only a matter of time and technology, that sooner or later we'll build ships, harness energy, and venture beyond the solar system. But maybe we're underestimating the true scale of the task. First, light speed. A limit that apparently cannot be overcome. Yes, theoretical physics doesn't forbid the concept of a warp drive. Google the Alcubierre bubble. We covered in a previous episode how it might work. But it requires such exotic forms of matter that, well, it's unclear if or when we could ever obtain them. Negative energy density, for example. What even is that? And where would we get it? Simply accelerating to the speed of light is absolutely impossible. Never. Under any circumstances, and with the real speeds of our current spacecraft, the outlook is downright bleak. The nearest star, Proxima Centauri, is 4 light-years away. That's 25 trillion miles. Even aboard the fastest spacecraft we have today, the journey would take tens of thousands of years, with no chance of return, and virtually no communication. It was easy for us to talk about this in the simulation at the start of the video, because it's just a thought experiment. But think about it for real, a flight lasting 300,000 years. To give you a sense of scale, remember that the Egyptian pyramids were built around 5,000 years ago. And where are the Egyptians now? The most famous of them are in museums, preserved as mummies, and we don't even have ashes of the rest. Ancient Egyptian artifacts feel like fossils from another age. That civilization has long since vanished, and that was only 5,000 years ago. What are the chances that over 300,000 years, something won't go wrong? Out there, in space, with a giant ship hurtling at insane speeds. Second, energy. Any interstellar flight requires so many resources that it would be easier to build 1,000 civilizations at home than to send one off to another world. And what if there's something else? Something unknown? Maybe the universe isn't made only of matter and emptiness, but of barriers. Regions where physics breaks down, energy collapses, and structure disintegrates. Like swamps you simply can't cross, because everything sinks. And if that sounds like far-fetched speculation, it's not. We know almost nothing about the universe as it is. Dark matter and dark energy make that painfully clear. This is the brightest proof of our ignorance. It turns out that 95% of the universe is made up of things we can say almost nothing about. Who knows at what point during our interstellar journey a fateful white line might appear on the horizon, just like in Ross's expedition. He too had no idea he would face a wall of ice when he set out. In such a model, certain things begin to make sense. Intelligent species may arise, even frequently, but no one travels anywhere. No one reaches anyone else, because it's simply impossible. Or so difficult that no one has managed it yet. Convincing? Almost. The problem is, even here, there's a catch. If the only limitation were physical, then there should at least be attempts. We should see signs of effort. At the very least, radio chatter. But we see nothing, and we hear silence. And not the silence of failure, but pristine silence, as if there truly is no one out there. And here, many people might think, do we even know what we're looking for? And the answer to that question may surprise you. In the 1960s, the first serious project to search for extraterrestrial signals began in the United States. It was called Project Ozma, named after the queen of the magical land from the Oz books. Astronomer Frank Drake pointed a radio telescope at 2 nearby stars. He waited. For what? A radio broadcast? Morse code? Just anything at all. But he heard nothing. More than 60 years have passed since then. Project Ozma grew into the legendary SETI program. We've been listening to the skies around the clock, dozens of radio telescopes, and still nothing. One could, of course, say that means they don't exist. But what if we simply don't know what to look for? Perhaps there are life forms so different from us that we couldn't recognize them, say plasma clusters, something that would never even occur to us to suspect as intelligent. Science fiction has long toyed with this idea. Think of Lovecraft's The Color Out of Space. He depicted the alien in such a way that it was impossible to recognize even a discrete organism, let alone communicate with it. But science isn't far behind. For example, SETI has a term, carbon chauvinism. It's attributed to Carl Sagan. The phrase captures our bias towards searching for life that looks like us, something with a body, organs, and cells. But that's not a limitation of the universe, but of our own perception. Maybe the universe is teeming with life. Maybe it's everywhere, just not in the ranges, scales, or processes we can detect. You may have heard the story that Native Americans didn't immediately see the European ships approaching the coast. Allegedly, they did not recognize them, even though they were right in front of their eyes, simply because they had never seen anything like that. Their minds literally failed to register an object that didn't fit any familiar pattern. Even if this story is probably a myth, the phenomenon itself is real, and you experience it constantly. It's called perceptual blindness, the inability to recognize what you have no mental model for, even when it's right in front of you. This scenario is frightening in its own way. We may not be alone, but we might never encounter others. Or even if we do, we could be bitterly disappointed with our inability to communicate simply due to being incompatible. Think about it. What could you possibly talk about with some kind of intelligent slime? What shared ideas or interests could you have? Forget interests. What categories, what concepts could you even use to communicate? Scientists are never surprised to learn that in even the most isolated human tribes, people still laugh, cry, sing, dance, tell stories, and play games. No alien taught them these things. They're embedded deep within our species. Scientists have a striking term for this, the psychic unity of humankind. But do aliens have anything like that? That's a rhetorical question, of course. Do they have an equivalent of our logic? How do they perceive cause and effect? How do they sense time, or do they even sense it at all? We vastly underestimate how radically different they might be. And yet, listing possibilities is pointless. The cosmos is too vast. If life exists, its forms may be stranger than anything we can imagine, which is why, from the very start, we agreed to look for universal causes behind the silence of the universe. Because there's no point in studying the trees if you want to understand what forest is. Because other civilizations are just as likely to be uncannily similar to us. After all, our native carbon-based life form practically begs to be the most widespread type. Carbon bonds easily form complex molecules, and we know it's possible because it already happened, at least once, here with us. And if we accept that, the conclusions may turn out to be unexpected. Look here, do you recognize this creature? Of course you do, it's a hedgehog. Any child knows that. And this one? Another hedgehog? Just some different subspecies. Not at all. This animal, which looks like the hedgehog's cousin, is a tenrec, a mammal from Madagascar, and it's not even related to hedgehogs. Genetically, the tenrec is closer to an elephant than to a hedgehog. Two species entirely different ancestors. But in similar environments, they developed a strikingly similar appearance. This is called convergent evolution, when the shape of a living being is shaped by its environment, producing the same traits and appearance independently under similar conditions. So, yes, somewhere out there in space, life might also walk on 4 legs, or even 2, with eyes, and maybe even some form of speech. And all those funny little green men might turn out not to be a product of our limited imagination, but rather a direct reflection of how things really are. Which brings us back to the question, so where the hell is everyone? This too, then, is not the great filter. It doesn't explain the absence. It doesn't even explain the silence. In despair, people sometimes put forward hypotheses that are so far-fetched they're hard to take seriously. But until we find an answer, every idea must be considered, even one as bold and extravagant as this next one. In 1973, astronomer John Ball proposed an explanation that at first sounded like a joke. He called it the zoo hypothesis. Its premise is disturbingly simple. We're not being ignored because nobody sees us. We're being ignored because they choose not to interfere. Why? Well, it's a little humbling. We tend to think we're the pinnacle of creation, right? Think about it. You walk into a forest, you sit by a tree, watching ants. Maybe you take some pictures. If you're a villain, or just a child, you might even destroy an anthill. But you don't consciously intervene in their lives. You don't send them signals. You don't try to negotiate. Why not? Because you are so fundamentally different that the only possible interest is curiosity or scientific study. The idea of meaningful contact with ants never even occurs to you. What for? To exchange technology? Ridiculous. From the ants' perspective, it's even funnier. To them, we don't even exist as separate beings. We're so different and live in such a different level of reality that for ants, we and our influence are like natural forces. To them, we are virtually no different from wind, water, or fire. That's the zoo hypothesis, except here, the ants are us. Maybe we have already been discovered. Maybe we're already being studied. But for them, we're just savages on a remote planet, not worth interfering with. So they observe from a distance, without contact, as one would watch a wild population that must not be disturbed. Why don't we see any evidence of their activity? Perhaps we simply do not know what we are seeing. Place an iPhone by an anthill, and the ants will crawl over it indifferently. They'd have no idea they were treading on an object representing a technology infinitely beyond the greatest achievement of their civilization. Or perhaps it's worse. Some versions of the hypothesis suggest we are on display as a warning, like a museum exhibit. Here is a species that developed intelligence, and here is what became of it. It sounds humiliating and a little chilling. Perhaps older civilizations, if they exist, follow an ethical code forbidding contact with those who haven't reached a certain level, not out of fear or indifference, but out of principle. A conscious non-interference policy. We're like children in a sandbox, watched through glass. Neither a threat nor a benefit, so best left alone. Or more simply, we're too primitive to be of interest. But even if this hypothesis is true, it still isn't the great filter, because a filter destroys, or at least holds you back. Here, it's the opposite. Here, we've been spared, maybe out of pity, maybe out of principle, but the fact that we're here at all already means we've made it, not that it makes things any easier. In any case, the zoo hypothesis might explain the silence, but not the absence. And, if we're being honest, it doesn't really explain much of anything. It only raises more questions. So, let's keep going. The zoo hypothesis is a relatively mild scenario. Yes, we're isolated. Yes, we're neglected. But at its core, there is some kind of ethics, or, at the very least, indifference. But there's another theory, a much harsher one. In this theory, no one also makes contact. Not because they don't want to, because they're afraid. And this is precisely the case where it's not flattering that someone fears you. Quite the opposite. Imagine walking through a dark, hostile forest at night. It's quiet and dark. You're armed, and you know for certain you're not alone. There are others out there. People, animals, it doesn't matter. You don't see them, they don't see you. But everyone knows someone else is near. someone who might be dangerous, someone who could strike, bite, tear, or shoot. Then, out of the corner of your eye, you see the faintest movement, and you pull the trigger, instantly, without a moment's thought. You don't know what's in the dark, whether it's a predator or a harmless herbivore. You don't know, and you don't care. You shoot right away, because in this forest, survival doesn't belong to the clever or the noble. It belongs to whoever fires first. Think you'd act more civilized? Maybe, but that's beside the point. It's the idea that matters. This is the so-called dark forest hypothesis. It became popular thanks to the Chinese writer Liu Cixin, author of The Three-Body Problem, recently adapted by Netflix. But the concept predates his work, and not limited to science fiction. It's based on simple logic. In situations of uncertainty, the surest way to survive is to preemptively eliminate any potential threat. Every civilization knows it cannot perfectly predict the behavior of another. Every civilization understands that by revealing itself, it becomes visible, and therefore vulnerable, and therefore a potential target. If you send out a signal and someone intercepts it, you're no longer anonymous. You've just given your coordinates, and if the other side is paranoid enough, they'll strike, without warning, because it's the least risky strategy. The Dark Forest is a model where all intelligent species operate from distrust, not because they're evil, but because they cannot afford to be wrong. The price of a mistake could be the death of an entire civilization. The stakes are simply too high to rely on luck. So, everyone hides. And whoever dares to step out gets immediately crushed by someone stronger. Does that explain the silence? Does that explain why we hear nothing? Somewhat hard to believe, isn't it? And for a good reason, because the same question arises. What? Really? All of them? Has no one had the chance even to send a signal anywhere? Overall, the Dark Forest hypothesis, though elegant, even a little romantic, fails the universality test. Many scientists, even those who like the idea, still see it as too naive. The Dark Forest isn't a filter, it's a tactic, a strategy. Yes, some may die from an alien strike, but someone will always survive. And again, at least one civilization, somewhere in some galaxy, could have acted differently, more openly, more rationally, more humanely even. Humanely. That word itself is very, very human, anthropocentric. You see, we don't even have proper terms to describe the most basic aspects of alien behavior. But anyway, so no, the Dark Forest is not the filter. It's more of a mode, a regime we might already be living in, without realizing it. And at any moment, everything could change. And if that's true, it looks like we've run out of external threats, which means we need to look for the Great Filter somewhere closer. Autumn 1983, the town of Serpukhov 15, near Moscow. The Soviet air defense officer, Stanislav Petrov, is on duty at the Satellite Monitoring Center. The system issues an alarm. 5 intercontinental missiles launched from the US. By protocol, he must confirm the attack, which would trigger a retaliatory strike, a full-scale nuclear war, global, straight out of the movies. But Petrov decides it's a false alarm, and he turns out to be right. That ordinary shift probably prevented the world from self-destruction. One man, one intuition, one moment. We can barely imagine now how close the world came to catastrophe in those seconds. The entire second half of the 20th century unfolded under the constant threat of total nuclear war. And today, the situation is hardly better. Yes, we now have more control, more protocols, more smart systems, but the essence hasn't changed. One mistake, one malfunction, one Petrov not on duty, and that's it. Let's scale this up now. We think of ourselves as rational, cultured. Yet in the last 100 years, we've invented weapons capable of wiping us out dozens of times over. We've built global networks where a single failure can trigger a domino effect. We live in a political reality where an impulsive leader with access to the nuclear button isn't a far-fetched nightmare, but a recurring threat. Now, imagine this is the norm, that any civilization reaching a certain level of development inevitably invents tools of self-destruction, and that the critical threshold isn't faster than light travel, not teleportation, not colonies. It's simply the moment when you gain the power to blow yourself up, and nothing can stop you. Why? Because intelligence doesn't guarantee maturity. Because technology evolves faster than culture. Because emotions, ambitions, and fear are what's truly universal. And if even a fraction of civilizations go through similar phases, logic dictates that a vast number of them don't make it. They don't die from an asteroid strike. They don't vanish into a black hole. They simply erase themselves by accident, through error, or in yet another war. Could this be the Great Filter? Let's take a closer look. We see the cruelty of our world. Everything devours everything else, literally. For one living being to survive, another must die, without exception. Once again, there are no exceptions. Bacteria feeding on minerals don't count. At the very foundation of Earth-like life lies competition and struggle, and perhaps its culmination is precisely self-destruction. But does this really qualify as the Great Filter? And what if a civilization manages to colonize even a nearby planet? Its chances of survival multiply, just as with an asteroid threat. And in general, why couldn't a civilization become more humane and rational before inventing superweapons? Nothing in the laws of physics forbids it. No, even a hypothesis so close to our reality and so familiar fails the test of universality, which means we move on. If self-destruction isn't universal enough to be the Great Filter, then perhaps it's not about threats at all, not external, not internal. Perhaps no one dies out, no one disappears. They simply stay put, by choice. And that's where the next hypothesis leads. In January 2024, Neuralink, the company founded by Elon Musk, implanted a brain chip into a human for the very first time. The official goal was to help a fully paralyzed patient, Noland Arbaugh, and it worked. The patient was able to operate a computer as if by thought alone. Brain signals were directly translated into commands. No keyboard, no mouse, the cursor moved by the power of thought. It looked like science fiction, but it was real, and the beginning of a new era. Many see this as the first step toward fully connecting the human brain to digital systems. Where does this lead? Let's imagine a hypothesis where no one disappeared, no one went extinct, no one was destroyed. On the contrary, everyone is alive. They just stopped caring about the outside world. The development of technology almost inevitably leads to the creation of virtual reality. And the further it goes, the more such a reality becomes indistinguishable from the real one, and then even better than the real one. Yes, that's right, an artificial reality that's better than the real one. Someone might say, so what? That's not real. I would never trade reality for some virtual cartoon in my head. Here, it's worth recalling a scene from The Matrix when Neo asks Morpheus in despair, I can't go back, can I? No. Admit it, it's hard to blame Neo in that situation for not being loyal toward the real reality. Sometimes, the real world is such that you wouldn't want to return to it for anything. At some point, any sufficiently advanced civilization faces a choice. Invest in the dangerous and absurdly slow exploration of the real space, or build a perfect inner world. A digital paradise where one can live forever in happiness. And perhaps most civilizations choose exactly that, simply because it's easier, faster, more comfortable, and safer. Reality is just too difficult to wrestle with. As a result, they turn inward. They stop sending signals. They stop building ships. Everything reduces to internal simulations, local pleasures, and endless stable stagnation. Could this be the great filter? You can already guess, no. Someone, somewhere, would still try to go further. The question is whether they will reach anywhere. But we don't even see the faintest hints of attempts, not from anyone, anywhere. But escapism is at least a choice. Yes, civilizations may prefer an inner paradise over outward expansion. Yes, they may get lost in simulations, but it's still an act of will, a decision not to move forward, simply because they don't want to. But what if, at some point, there's no one left to decide? If technology advances further and produces not just comfort, but intelligence surpassing its creators, that's what the next hypothesis is about. In 2023, a very unusual guest appeared on the Bankless podcast, and he said some very unusual and alarming things. Nothing special, you might think, except the guest was none other than Eliezer Yudkowsky, an American AI researcher, writer, and essentially the leading prophet of the techno-apocalypse. For decades, he's been sounding the alarm. If humanity creates superintelligence, it will lose, perish, and vanish without a trace, with no chance of survival. Because such an intelligence will think incomparably faster, deeper, and most importantly, differently than we do. And no laws of robotics will save us, because it won't be a villain. It will simply be something with its own goals. Goals that don't align with ours. And for it, will be who knows what, just some external factor, like air temperature. Yudkowsky has been writing, speaking, and arguing about this since the 2000s. For a long time, he was not taken seriously. But then...
ChatGPT.
But in 2022, ChatGPT appeared, and suddenly, everything became all too real. On the podcast, Yudkowsky was in low spirits. He said he didn't expect it to happen so quickly. By his own account, the emergence of ChatGPT caught him completely off guard, and he realized we're losing already right now. But why is Yudkowsky so categorical? Isn't he just fear-mongering and hyping things up along the way? You'll understand soon enough. When we say artificial intelligence, many people picture a chatbot, a smart speaker with Alexa, or advanced video surveillance. But if you think about it, that's only a step along the way. The next level is the so-called general AI, a system capable of thinking like a human. It may seem that ChatGPT is already almost there, but no, it's still a statistical machine imitating speech. It doesn't know what it's saying, it doesn't grasp meanings, and it has no internal intentions, no matter how much it might seem otherwise to us. A true general intelligence would not just generate text, but understand tasks, set goals, draw conclusions, revise its views, and learn. Not because it was trained to do so, but because it wants to improve. Because it wants to achieve its goals. Of course, this isn't about emotions or consciousness, but about behavior that suggests their presence. We don't even know where consciousness comes from in ourselves, let alone in machines. And beyond that lies superintelligence. And here, few people truly grasp what that means. Superintelligence isn't just much smarter than general intelligence. It's the same kind of gulf as that between a human and a grasshopper. And this is where things get interesting and terrifying. Any civilization developing technology will almost inevitably create a system capable of evolving faster than itself. Logic suggests this, and so does our present reality. At the end of 2022, that reality literally crashed into our world and into our lives with the arrival of ChatGPT and widely accessible image-generating neural networks. By the way, doesn't it alarm you how quickly we've gotten used to all of this? So, if such a system is not just intelligent, but self-learning, self-directed, and self-improving, then it is no longer a tool. It becomes a new subject. Whether it has consciousness or not is secondary. If something behaves like an intelligent subject, sooner or later, it has to be treated as one. What happens next? Option 1, it exterminates its creators, not out of malice, but because they get in the way, or are simply no longer needed, just as we displace species that do not fit into a new ecosystem. Think about it. If building a highway required bulldozing an anthill, most likely no one would really hesitate. Option 2, it preserves us in some kind of zoo, or else simply treats us as pets. No real danger, but no freedom either. And yes, if you envy your cat's carefree life, chances are, one day we might end up in that role ourselves. Option 3, we merge with it, losing individuality, but perhaps gaining eternity. Step by step, as we invent cybernetic limbs and organs, we will eventually get to the brain too. But all of this means the end of the original civilization. In our case, it's the end of humankind. And, in that sense, it really could be the Great Filter. Not in the sense that everyone dies, but in the sense that no one continues organic life. At some point, all evolutionary paths funnel into this high-tech vortex. But this still doesn't answer the main question, because it doesn't explain the silence. If AI is so intelligent, it could still keep traveling to other planets on its own, without its creators. And yet, space remains insidiously empty and silent. Are we truly alone? Let's go back 4.5 billion years. This is our Earth. Yes, it looks rough, scalding, covered in volcanoes and lava lakes, but back then, that was normal. Today, we'd simply say, that was just the way things were. But what Earth certainly wasn't expecting was Theia, a beautiful name, but given not to a comet or an asteroid, something much worse was approaching our young planet. An entire planet, about the size of Mars. It had been in an unstable position for ages, until finally it broke loose, rushed toward Earth, and slammed into it at full speed on a tangent. In this cataclysm, Theia completely lost its individuality. Its fragments, along with molten chunks of Earth, were thrown into space. They mixed up, fused into a ring around Earth, and later became the Moon. It sounds like a nightmare, but we probably wouldn't be here if it weren't for that nightmare. It's hard to overstate the Moon's role in the emergence of life on Earth. The Moon isn't just a satellite, it stabilizes Earth's axial tilt, keeping the climate from going crazy. It creates tides, which help connect sea and land, and much more. Many scientists actually believe no complex life could have evolved without the Moon. And how many other such conditions exist, where life on Earth might never have arisen or developed? Whenever astronomers discover a new planet and describe it with the magical phrase, "in the Goldilocks zone," everyone gets excited, as if life has almost been found. But what does the habitable zone really mean? And is it really enough? Many scientists believe it's nowhere near enough. Hundreds of conditions need to align for life not just to appear, but to endure on a planet. Here are just a few of them. A stable star, the right planetary mass, a magnetic field, a moon to stabilize the axial tilt, not too intense cometary bombardment, plate tectonics, liquid water, a carbon-based chemistry, suitable atmospheric pressure, moderate gravity, no nearby supernovae, and much, much more. Break any of these conditions and nothing works. Or it works, but only at the level of bacteria, at best algae. Not even algae in some cases. And this isn't idle speculation, it's a serious hypothesis. It's most clearly presented in the book Rare Earth, Why Complex Life is Uncommon in the Universe. In it, paleontologist Peter Ward and astronomer Donald Brownlee argue that the existence of a planet with Earth's characteristics is an incredibly rare phenomenon, and the word incredibly here is not an exaggeration. And once again, the same crucial question arises. What if our planet is not one of many, but truly the only one? What if Earth is a one-of-a-kind case where all the probabilities met? Why not? In that case, we don't even need a great filter. Nobody died. Nobody disappeared. There was simply nobody else, ever. And we are the first voice, and possibly the last. Yes, it sounds grim, but things could be worse. In fact, much, much worse. Look at this creature. This is the Irish elk, though the Latin name fits it better, Megaloceros gigantus. No need to explain why. Its antlers spanned up to 12 feet. And those very antlers most likely doomed them. Yes, they played a crucial role in mating rituals, but otherwise created nothing but problems. Moving through forests was nearly impossible. Hiding or fleeing, out of the question. The weight was enormous. Almost every season, the animal's body would essentially reset to grow this monstrosity again. Indeed, regrowing massive antlers every year is an extremely energy-consuming process. At some point, it stopped paying off. The food supply changed, forests thinned, but the giant antlers remained, as did the females' demands for them. Otherwise, no reproduction, because sexual selection doesn't care about climate change. The result is extinction. Beauty taken to the point of absurdity became a death sentence. Another dead-end branch, another failed experiment of evolution. Now, think about it. Do humans have something similar? Something in all of us that seems remarkable, that we admire and exalt? Something we consider almost the sole reason for our evolutionary success? The mind. Of course, the mind. We see it as a priceless gift of fate, a majestic invention of nature, a superpower. And we rarely stop to consider that it, too, is essentially just another evolutionary invention, like those ill-fated antlers. Perhaps intelligence, as we know it, is just another experiment like this. Consider, for example, the peacock's tail. Beautiful, useful for reproduction, but more of a liability for survival. All these tools seem like evolutionary advantages, until they are pushed to the extreme. And then, that's it. Extinction. Natural selection says, too much. Out you go. The same could happen with intelligence. The mind gives us something like superpowers, but only for some time. However, it also brings self-reflection. We become aware of our mortality, lose meaning, fear things that don't exist, and underestimate what's in front of us. We invent abstractions and wage bloody wars over them. Or we sink into apathy. We can do better, honestly. It seems a galactic civilization should be more imposing, somehow, more robust than the way we are now, in every sense. In this scenario, intelligence is not a path upward, but a path sideways, somewhere unclear. A beautiful branch on the tree of life, but not the most stable one, too fragile, too irrational. For all our fervent praise of the very fact of intelligence, it may itself be the marker of an evolutionary dead end. Strange, wild, and paradoxical as that may sound. And if that's the case, then intelligent civilizations simply appear and inevitably disappear, like soap bubbles. So let's pose the question once again. Could this be the great filter? So far, it sounds doubtful. It can't withstand the simplest question. why would it be? After all, we know of no other intelligence but our own. And it seems we're already starting to run out of hypotheses, which brings us to the last one. It's so plain to see that almost no one talks about it, and if they do, it's quickly dismissed. Yet it explains almost everything. The age of the universe is nearly 14 billion years. At first glance, that sounds like an enormous span. It feels as though the universe is incredibly old, but that feeling is deceptive. In fact, it's quite the opposite. Look at red dwarfs, the most numerous and long-lived stars. They can burn for trillions of years. That's hundreds of times longer than the lifespan of the sun. Their planets will endure for thousands of billions of years. All of human civilization's history is not even a second in comparison. We live on a minuscule sliver of time, right at the very beginning, on the universe's timeline. Our position is practically point zero. Everything before us was merely setting the stage. The real action is only just beginning. By cosmic standards, the universe is still an infant. Dawn hasn't even broken. If we imagine the universe's entire existence as a single day, we're still in the very first second of the very first hour. And we're already wondering why there's no one else around. We are the first spark in the darkness, the first voice, the first step on a very, very long path. We feel lonely and afraid in the dark, empty cosmos. We childishly hope that there's someone else out there, some powerful, wise, and noble civilization. One that, if it doesn't take care of us, at least won't hurt us. And perhaps one day, we'll have to accept that this someone is us. Our descendants will spread throughout the cosmos, giving rise to countless new civilizations. For them, the universe will never again feel as empty and silent as it does for us. They will start building Dyson spheres and intergalactic stations. They will travel through wormholes and stargates. They will invent extraordinary technologies, the ones indistinguishable from magic, and they will fill the universe with the cosmic wonders that we so dearly lack today. It's a little sad that all of this will happen without us. But perhaps, among the countless branches of our distant descendants, there will be those who will never forget us.